Hey guys, welcome back to my channel. So today we're going to be talking about how to convert from line structure to Newman projections and then to Fischer projections. So right now we have this structure right here. There's a chlorine with a dash, a hydrogen right here with a wedge. Sorry about that. With a wedge right here. And then we have an isopropyl group with a dash and a hydrogen with a wedge. So this is a C2 carbon right here. I'm gonna color and circle in blue. And then a C3 carbon in the back right here. So now let's get started. So to convert it from line structure to Newman, we have to first look at it from a perspective right here. So let me draw the eye. Here's an eyeball, right? And it's looking specifically at this angle right here. So to convert this line structure to Newman, we have to first draw like a simple triangle right here, and then something like this, right? So this intersection right here is C2, and this circle right here is C3. So now let's get started. C2. So usually the dashes, I would typically put on the left side of the, so here's dash, and then here on the right side, I'll put it on the wedges. So meaning on the C2 carbon, which is, I'm gonna circle the C2 carbon right here, we would put, starting from there with this triangle, or somewhat of a triangle, C2, I'll put a chlorine right here, and it looks like the CH3 is, the methyl group is pointing up, and then the hydrogen wedge is on the right. So from there, we can draw our circle, which is a C3 carbon, and then on the left is an isopropyl. This isopropyl, I'll circle it in green. It's right here. And then we have our hydrogen, which is on a wedge. And then our bottom is our methyl group, CH3. So that's from Newman, from line structure to Newman. Now from Newman, we have to convert it to Fischer. In order to do that, we have to get this structure, the Newman projection. So I'll redraw it right here. And then now we're gonna convert it to where we can draw it into a Fischer projection. So meaning that I'm gonna rotate all of the front C2 carbon to the right, to the right, to the right. So therefore, it's gonna be looking like this. CH3 is right here, and then chlorine would be right here, and then hydrogen would be right here, and then we draw this, and then that's C3 carbon will not change, only the C2 carbon will rotate, and then we draw the isopropyl. Isopropyl should be actually where it should be originally, and then this hydrogen right here. So therefore now you can see this conversion from the blue to the green, right? As I twisted the triangle, the C2 carbon, and put it towards down here. So I rotated it somewhat of a 180-degree fashion in relation to this methyl group. From there, now I'm gonna unwind this like as if we're doing it, making a pancake waffle system. So if you're not familiar with the waffle makers, let me try to draw it in blue. a waffle maker would typically have like a hinge and a here. So you put your waffle liquid in here, and you close this handle, and it becomes, and that's how you get your waffle, right? So, but specifically, I'm gonna open it from this. I'm gonna leave this alone, and hence the CH3 is that system right there, and I'm gonna leave it alone. So, and I'm gonna open it. So it's basically opening a waffle from looking at, not from a bird's eye point of view, but rather from a groundhog point of view, where you're looking at from, let's say, an ant on the floor looking up. So actually, I take that back, not from here, but looking at it from here, which is similar to the CH3 point of view. So hence, the CH3 will stay the same. And then you have your chlorine right here, and then your hydrogen right here. And then you have your, as you're unwinding everything, you have your CH3 there, which is right here. And then the isopropyl right here. Let me try to write that better. And then your hydrogen there. And so that's how you convert from Newman to Fischer. Awesome. Thank you so much for your time, guys.